Hello, everyone. I'm Duong from PSOS program. I have a strong passion for applying the Raman spectroscopy to detect the cervical cancer. Fortunately, I had an opportunity to intern in Dublin, Ireland, focusing on using the Raman spectroscopy for detecting the cervical cancer. Therefore, today I would like to introduce you what I have accomplished during my summer internship through presentation, comparisons of Raman spectrum quality between self-collected and clinician-collected samples for cervical cancer diagnosis. Speaking of the cervical cancer, it is the uncontrolled growth of cells in the cervix, and it can affect or impair the sexual functions or ability to have children of the women, because we have to remove a part or the whole cervix if the cervical cancer come to the final stage. Faced with the situations of cervical cancer, the women should receive full HPV vaccinations. Besides, they have to regularly monitor their cervix. In the past, we use cytology. This is the method to examine the cervical cells under the microscope to detect the abnormalities. This is the method with the high specificity, but taking much time and having low sensitivity. Therefore, the HPV testing has been introduced because it's faster, cost-effective, and have high sensitivity. Nowadays, with the development of the Raman spectroscopy, the Raman method is considered as a potential method because it can give us the biochemical fingerprint. This is the information of the cell, and it's also the non-destructive sample and minimally invasive method. But for doing the Raman measurement, the woman have to come to the hospital for doctor or technician to take the sample first. It seems to be time-consuming, expensive, and even uncomfortable for personally. Therefore, some countries like US, Ireland, and Canada have introduced a new method. It's called self-collected sample methods to replace the traditional method. But the key question is self-sampling equivalent to the technician samplings? To deal with the problem, we have to compare the spectrum quality between the self-collected sample and the sample from the doctor. Speaking of the Raman spectrum quality comparison process, it involves 5 steps. First, the sample will be collected by doctor and taken at home by volunteers, especially for the volunteer samples. They can be stored on different days to assess the impact of time on their spectrum quality. Then the sample solutions will be sprayed on the glass slide, and after that we can put the glass slide with the samples into the confocal Raman microscope to take the Raman spectrum. After obtaining the raw Raman spectrum, we have to process the data. By noise filtering, baseline correction, and normalizations to compare the spectrum. And finally, we can calculate the mean Raman spectrum and use BCA to analyze them. Here are some interesting findings in this study. First, this is the calculating the mean Raman spectrum for comparison between 2 different sample types. As you can see in the picture, the black dashed line represent for the standard sample or for the sample from doctor, and all the lines represent for the volunteer samples. We see that all spectra are nearly identical. However, at the peak at 1486 per centimeter, the intensity of doctor sample is higher than others. That peak is really important because when we see in the biochemical components of cell charge, that peak correspond to presence of protein, and we know protein is a marker for detecting the cervical cancer. So, but in generally, we can say the quality of the Raman spectra of the sample, of all sample, was similar, except at that peak of 1 for a 6 per centimeter, because that peak is just one of all factor to detect the cervical cancer. Next, this is the results of a BCA analysis. I use BCA because I want to reduce the data dimensions and compare and want to see the difference between the samples from the volunteer on different days compared to the standard samples from the doctor. On 2D scatter BCA plots, we see the black dots represent for the doctor sample or standard samples, and all the dots represent for the volunteer samples. Respectively, the blue dots for the day 0, the purple for the day 2, and the red for the day 8. It's clear to see that the red dots are scattered a lot, while all the dots are concentrated on the original of the coordinator 00. That means the Raman spectral quality change a lot over the time from day 0 to day 8. The best solutions here to measure the sample with the limited days. Especially the best either is take the measurement on the same day of the sampling. In conclusion, there are three main points we have to focus. First, the applications of Raman spectroscopy for cervical cancer diagnosis is a significant potential because it is the minimally invasive and non-destructive sample method, and it can give us more information of biochemical components of the cell to detect the cervical cancer. Second, the procedure to compare between different samples involves 4 main parts: sample preparations, Raman measurement, pre-processing the data, and data analysis by using PCA. Finally, we see that on the same day, the Raman spectral quality between the cell-collected sample and the sample from the doctor is nearly similar, but on the different days, the spectral quality of a cell-collected sample will gradually reduce over the time. From those results, we can say cell sampling can replace for the traditional method collection by the technician, but only limited days. That's my presentation. Thanks for your attention.